Hello, everyone. This is Dr. Olson, and I am holding a review class tonight for the first 4 weeks of what we've been learning in our class. So I have this on recording in case some of you aren't able to join us and would like to review. And I'm waiting now for some students who have expressed an interest in joining, so we'll see if they come on. So just stand by, please. Is this Carolyn?
Oh, yes. Hi. Can you see me?
No, I just see your name. Well, I see Devin Fabian.
Right. That's my
Oh,
that's my son's
oh, account. Well, that's
yeah.
fine.
I don't even know why. We have two different Google accounts, but I guess he's the one that used this computer last.
Yeah,
Uh,
probably. Um, I have this on recording, and I hope you won't mind. I'll ask
mm-mm.
any of the others that come on just in case some other students can't join us who want to, and then they
Uh,
can just listen to the recording.
mhm.
So, how have you been?
I've been okay. How are you?
I'm good. Here comes.
Holiday was good?
It was. It was really nice. I
Oh,
hope yours
good.
was also.
Yeah, yeah.
Here's Anna or
Oh,
Anna.
good.
Need to.
Oh, good. Let me go get a pen.
Hi, Anna.
Hi.
I called you Anna. Anna, I have this on recording so that if somebody couldn't join us and would like to follow with the review, we can offer this to them. Are you okay with being recorded?
Yeah.
And I think that there's one more student coming.
Okay. I'm here.
Started. I'm not going to wait too long. I only have a 40-minute window with my Zoom account, and I don't want to spend too much time since you all are here on time. Carolyn, are you back with your pen?
Yes, ma'am. I'm
Okay.
here. Sorry. Yeah, I'm trying to figure out the video thing, but it's not working that
Oh,
well.
well,
Hi, Anna.
Anna Carolyn is on with us,
Yeah,
and
it says Devin, but it's me. That's my son.
I'm going to wait until 5 after, and then we'll just get started with whomever's on. I have a little bit of preparation here for you,
Mhm.
and I'm going to share my screen just to have it up. And you should be seeing a document
Yes.
reads independent variable. Well, why don't we start with you guys asking me questions?
Okay.
Or do you feel like you don't know enough to ask?
Professor, so in my situation, I ask questions when I start doing the assignments.
Uh-huh.
Like when I
Yeah.
see that I'm confused with something, that's when I start asking you questions about it. So, but all the questions at once, I don't know.
All right. Well, let me go ahead and start with what I have put up here, and we'll go from there because I think what I'm going to share with you is pretty much across the board a bit confused by many of you. So let's just try to clarify some things. And one is I'm seeing a bit of a confusion on independent variable and dependent variable. The independent variable, and let me just write a quick hypothesis here. There's no. Okay. This is an appropriate one, don't you think? So for the hypothesis, which is in this case the null hypothesis, we always start on a level playing field and assume that there will be no differences, or if we're looking at correlations, we would say no associations or no relationships. But in this case, we will look at differences, and there's no difference between male and female nurses' pay. And do one of you want to identify what the independent variable would be in this hypothesis?
The difference between male and female.
Okay, the male and female nurses is our hypothesis here, correct? And the dependent variable then is what?
The pay.
The payment.
Yeah, the pay. All right, so what we're doing is we have an outcome that we want to measure, which is pay. It's got to be something measurable. And we are going to manipulate the pay or the male and female salaries. In other words, in our experiment, we have one group of male nurses and one group of female nurses, and we're going to look at what their pay is. And the male and the female nurses, that would be we're manipulating this part of our question because we're saying, you know, what are the male nurses being paid and what are the female nurses being paid? And if it's a male nurse, the pay might be such and so, and if it's a female nurse, it might be something else. So pay is what we are trying to measure, and that is our dependent variable. It's affected by the independent variable, either by a male nurse's pay or a female nurse's pay. Do you understand what I'm saying there? Because I'm seeing a lot of people do something like this. They're calling the hypothesis the independent variable. Well, I can't spell. They're writing something like this, several students, and that is incorrect. I don't know what that means even.
I am guilty of that.
The hypothesis is the hypothesis. The independent variables would be the male and female nurses, and the dependent variable would be the pay. And, you know, likewise, let's say there are no, we'll, okay. So this is actually, we're going to do a correlation here because we're looking at relationships. We studied correlations this week, so you're familiar with those. But we would not say there's differences because a correlation does not measure difference. It measures relationships. If there's an association or a relationship between the independent variables and the dependent variables. So the independent variable will be the same. It's the male and female nurses, their pay, and we're going to see if there is a relationship between their pay and the length of time they've been in the job. I'll call that the dependent variable. So we're looking at relationships between the two, the length of time in the job and the nurse's pay. Here in the first one, we're looking at differences. So we want to compare the male nurse pay with the female nurse pay. But in the second one, we're actually looking at relationships. Is there a relationship between the length of time a male nurse has worked with their pay and the female nurse with their pay? So I hope that that is clear. Now for the alternate hypothesis, or the H1, all you do is copy and paste and remove the no. That's all you have to do to write your alternative hypothesis, because now we are saying, let me remove that. Now we're saying, instead of there are no differences, we are saying there is a difference. I'll put an A there. There is a difference between male and female nurses' pay. So if we conduct the analysis, and this is for next week, we would, because we're looking at differences, we're going to be analyzing this using a differences test, which would be like a t-test, and we'll learn that next week, or maybe it's this week actually. By looking at the word differences, we know that we're not doing a correlation. We know that we're doing a differences test. In a differences test, if you have a no more than 2 independent variables, which this would be 2, then you would be doing something called a t-test. And that would be the analysis that we would use for looking at solving a hypothesis that is asking for differences or no differences. If we had male and female, and should we say what, and transgender nurses, then we've got 3 independent variables, and that we're still looking at differences between the 3, but we would not be using a t-test for that. We would be using something called ANOVA, which is really a t-test kind of on steroids, so for more than 2 variables. But we'll talk about that later, but I just wanted to show you that. But the hypothesis, the null hypothesis, if we fail to accept the null hypothesis, or if we say the null hypothesis is not true, then we accept the alternate hypothesis that there is a difference. So if our t-test comes out showing that we would have a difference, then we will accept, or showing that there's significance, then we will accept the alternative hypothesis. Now, what about our test parameters would we determine to decide if the p-value of our t-test is significant? Do you remember?
No, say that. I'm sorry, say that again.
Okay. What have we studied that would set a parameter or draw a line in the sand of what they would determine that the p-value is significant or not significant? In other words, that we would accept null
0.05,
hypothesis.
right?
Pardon me?
Less than
0.05.
5%.
Say it again. I didn't hear you.
I said 0.05.
Okay, and we call that what? We call it the alpha level,
Right, right.
right? Okay, so we usually set our alpha at 0.05 just because makes it easy for us. And so if the results of our p-value, which is the result of the statistical analysis, is less than 0.05, then we would accept the alternate hypothesis and reject the null. If the p-value is greater than 0.05, then we would accept the null hypothesis as being true. And I think most of you have that pretty well understood. But that's why when you present a study, you need to be sure, you need to write the null hypothesis so we know what is being tested. That's our test question. Then we need to include what the alpha level is, and we need to include what the p-value is. And those components tell the story. And if once you get used to those, looking at those components and reading them in studies, all of these studies are going to make sense to you when you're looking at research journals. Now, I wanted to show you, talk a little bit about distribution of data. And this is, of course, we call this a bell curve. And this is what we hope for. We hope that the data that we are measuring represents most people. And I mentioned to somebody, it's like you're making a stew and you want to know if you need salt in it. So if you spoon out a spoon of soup and you add salt to that spoon of soup, that's not really going to tell you how much salt you need in the rest of the stew. So you want to, here comes Alicia. So you want to be able to test the whole pot of stew, but you're not going to taste it all. You just eat the whole pot of stew. So, you know, you might just taste some of the stew and see how it tastes and add salt to it and then taste it again. So you're testing the whole pot of stew or the whole amount of data or the whole population by just sampling a little bit of it. And so that's what we do with statistics, because we can't measure the whole world, but what we can do is measure enough to get an idea. And so if the data that we have falls within a bell-shaped curve, then we've got a pretty good idea that our sample is pretty accurate. And we talked about standard deviation. So if we have this much data that's in the dark blue that falls under this dark blue, this middle part of the curve around the mean within one standard of deviation, then that is an indication that we've got a pretty good normal sampling of our data. And as the data will spread out in a bell curve, then we want, this would add up to 68%. So it's either on the negative side or the positive side of the curve. It doesn't matter. We just want the most of our data to fall within 3 standard deviations of our mean, which is right here. And that tells us that we've got a normal distribution. So 2 standard deviations would add up to about 95, and 3 standard deviations will add up to 99. So we've got a little bit of wiggle room right out here in these tails. And if you've read about a 2-tail test, what we're saying is that if we're testing within a 95% confidence interval or an alpha level of 0.5, any data that falls outside of this 95% of this curve will be considered no differences, because in other words, let's say most of the people like chocolate ice cream, so all of these people voted for chocolate ice cream. So we would say that that's no differences. But if some voted for pistachio, then that would be a difference, and it's going to fall out here, so in the tails. And so that might tell us that if our hypothesis is there are no differences in people preferring chocolate ice cream, then there are differences if some people out here, if enough people out here chose, I can't say it now, help me. You know what kind of ice cream, something other than chocolate. Do you understand that? Does that make sense? Are you with me?
Yeah.
I'm
It
not
does.
hearing anything.
It's-
You can say no. It's okay.
No, that makes sense.
Well, what I'm just trying to show you is what the bell-shaped curve means and what the 2-tail test means, because most of the tests we'll do are 2-tail. And what we want to, we throw all the data at it and see where it lands, more or less. In some of the studies, you're going to see that the test was done at a 95% confidence interval. And that means the same thing as an alpha level of 0.05. And so what that means is that in a normal distribution, 95% of the observations roughly lie within 2 standard deviations from the mean. And we've talked about standard deviations. Okay, so that's kind of what I have prepared here for this evening. And so if there's some things that you want to talk about, I'm open give you all the floor. And I'm going to stop sharing.
This is Alicia. Hello, everybody.
Alicia?
So,
Hi. So my only, it seems like I think I have it, and then I confuse myself.
Yeah.
So with
Okay.
no,
Before you go on, let me just point out that I am recording this. to share if anybody would like to have been involved in this and couldn't get on tonight for some reason. Is that okay with you?
Yes.
Okay. All right, go ahead.
All right. So in my chapter, what chapter was, our discussion for discussion 8. So I selected a two-tailed test, and my study was examining the parenting style and emotional maturity. So, and
Amelia.
I'm sorry.
So sorry, never mind. Sorry, I thought I was on mute.
Okay, so it was among adolescents across the gender. The study uses 50 males, 50 females. So after I got all my data, I looked at the conclusion. So it was perceived that the parenting style does not differ significantly across the gender. And then it says emotional maturity does not differ significantly among adolescents across the gender. I got confused. So my no would be, it does not, there's no differences in the parenting style and there's no differences in emotional maturity.
Okay, of male and female children, right?
Yes, across the
To be
gender.
specific with your hypothesis. You got to be specific. So there are no differences in parenting styles and
Maturity, emotional maturity.
emotional maturity among male and female children.
Right, they use 50 ages 15 to 18.
Okay. Now, what of that is your dependent variable? What are you measuring?
My dependent variable is the parenting style and emotional maturity.
Okay. All right. And the independent variable would be
Gender.
the gender, okay, or the male and the female children. And those are the things that are changing
Right.
in the experiment. Okay,
So
everybody.
where I got confused is
Anna and Carolyn, do you follow that hypothesis?
I do, now that you say it like that, yeah. Mhm.
Anna, are you good?
Yeah.
If you're not, say so. Don't be afraid. Okay, so Alicia, continue.
so now I'm confused. So when I write my null hypothesis and I state that there's no differences, I'm going to say at the end that the null hypothesis, that's where I'm confused at. I don't know what to say at the end. I know that it's a null, but I don't know. Are we rejecting it or accepting it?
Well, it depends on what your test comes out to be. Let me do another share screen. No, I don't want that. Wait a minute. Let me get out of this. Okay. There. Can you see my paper here?
Yes.
Okay. So I'm going to write HO there. Oops. Oh, let me just remind you all that my Zoom will only last for 40 minutes. So if we get cut off, just go back and click on that link again and we can get reconnected. That's all you have to do is just re-click the link. So,
Okay.
there are no differences between gender and or
Parenting style.
young children. No, I'll just put gender in parentheses, meaning male and female, and parenting styles and emotional something. Okay. Okay. Now, so let's see. In this one, let me just look at this. It's really, are you sure there are no differences in.
It said the perceived parenting style does not differ significantly across gender. Then it says emotional maturity does not differ significantly among adolescents across gender.
Mhm. Okay, so what we're measuring here, we've got male and female children. That's what we're that's our independent variable. We've got male children and female children, and then there are parenting styles, and we're measuring the emotional whatever
Maturity of the children.
maturity of the children and the parenting styles. So there are no differences between young male and female children. Are we measuring their emotional?
It just says emotional maturity.
Okay,
Let me see.
young male and female children's emotional what? I can't. I think emotional maturity and parenting styles. I think that's what this is doing. Okay, so really, it's the parent. I think what we have here is we're measuring emotional maturity of children, right?
Yes.
All right, so that's going to be our what? Dependent or independent variable?
The emotional maturity is the dependent.
Right, because that's what we're measuring. And the parenting style, since that's going to change, right?
Yes.
I have different parenting styles to see what happens, then that's going to be your independent variable. Because that's what's going to be manipulated. And this is what we're going to measure. All right. And so for the H1, then it would be the same thing, except we do what? This is for anybody.
So we're gonna either accept it or not accept it, right?
Yet, we're not there yet. I'm just talking about writing the alternate hypothesis.
So there is a difference.
Yeah, there are differences. We would just take out the no. Makes it real easy. Okay, now let's say because we're looking at differences, we're going to be doing a t-test. And so let's say that we conduct the t-test, and what did the p-value come out to be?
That's what I'm looking, because I posted it on. I'm looking up the journal now, or article.
Well, I'm just gonna
So they had, okay, the one p-value says p less, well, no, that's not one. The one I have is p is less than 0.01.
Okay, p equals, I'm just
Right.
0.001, you said? Yeah, okay, I remember reading that. Okay, so now with an alpha level set at 0.05, is our
Yeah.
p-value greater than 0.05 or less than 0.05?
Less than.
It's less than 0.05. So what that means, going back to this curve, is it means that it is falling way out here in the wings, and meaning that there are differences, because if it was greater than 0.05, it would mean that the results are falling under the curve, where there basically are no differences. So we've got a very small p-value, smaller than the alpha, which is the line in the sand. And what that will cause us to do is to reject the null hypothesis and accept the alternative hypothesis.
So are we writing that in the H1, we're going to say we're going to reject the null and accept the alternative?
And you can say that there's significance, because if there are differences, then we've got significance. If there's no difference, then there's no differences. nothing happened. But
And now that you put it like, now I can understand it and put it together and know what's what, because that's what was driving me crazy, because I was like, we're saying sample numbers, like the way we're doing it now makes me understand. I didn't understand before, and I was trying to put it together, and it was.
all right, well, good. Well, let me ask Carolyn and Anna. Now, this is telling me that we've got about 8 minutes remaining before we're going to get knocked
I have
off.
a question too.
Pardon me, Anna?
I have a question too.
Okay. What is your question?
Oh, okay. It's about the discussion forum 7
Mm-hmm.
for the age 0 and age 1.
Mm-hmm.
So you said that if we were analyzing differences, you age 0 and age 1 would be perfect. So what is the error there? Because I wrote age 0, there are no differences between diagnosing hypertension by using automated office blood pressure and conventional blood pressure.
Okay.
And then I had to rewrite the age 0 and age 1.
Well, didn't you do this? Didn't you do this? Didn't you do something like that? And I was telling you to not
No.
do that.
That
Okay,
might be me. I'm guilty of that one.
did that one. Okay. I'll have to look at that, Anna, and respond. I'm not sure. Can you read to me what I wrote?
You wrote, hi Anna, thank you for this study. Since we are using regression for the analysis, we are not analyzing differences, but
Okay. Because what we were doing, we were not studying differences. We were studying relationships, right? It was a correlation.
yeah. So
Okay. So what I was saying that if you're doing a correlation, what you are looking for are relationships, not differences. There are some tests that will test differences and some tests that will test relationships. And for correlation, that test tests relationships. But like what she's talking about here for this one, this is testing the differences. So that would be a different test that we're learning this week called a t-test.
So the word, so I should put there are not relationship.
Relationships, yes.
There are no relationship between. Oh,
Yeah.
okay.
Yeah, because it's like a math problem. If you're adding and subtracting, that's one thing. If you're multiplying, that's something else. So in this case, some tests will test differences and other tests will test relationships. So you need to learn which ones do which, and you will. And you're learning now that correlation and regression, they're pretty much the same. They test relationships.
Oh, okay.
And we're going to start with t-tests and ANOVA, and those are tests of differences. So then you'll say there are no differences for your hypotheses.
Okay. Thank you.
You're welcome.
My question is, when it says the assumption of the independent test samples, so I know that I had a random sample, I had a normality, and a homogeneity of variance. Those
good.
all five, that's what my study falls under.
Yeah.
Well, and then the last question that you asked in 8, I didn't understand. I just posted the numbers that were in my study, and that's where I needed help at.
Oh, I think I think which assignment is that one?
Number 8.
Yeah, I have the same question for the last question.
And what is the last question?
Let me see.
Uh,
It's about, let's see, it's not opening now. Number 8, the last question.
oh no, this is taking up my whole screen. I don't know how to make it little.
What is the last question that I'm asking?
1 second. So it says, discuss whether the findings in the study is statistic. No. Address the type of data required and entry assumption data that we are made.
I think I have it. It says discuss whether the finding in the study is statistically significant in reference to the alpha level, and the P level. Okay, so it's just subtracting one from the other.
Well, you know, if you've got an alpha level of 0.05 and your p-value is less than that, then it's showing significance. So you would
Significant.
reject
Okay.
null and accept the alternative.
Okay.
You know that,
Yep.
right?
It
Anna,
was,
you know that, right?
yes, but it was another one that I had a question, another assignment. It wasn't
Now,
that one.
we're gonna get bumped off here in less than a minute, so be prepared.
So I'm talking about, I think this one, discussion forum 9, last question is the one. It's the one that says, note any post hoc tests that were presented and discuss the purpose.
Yeah, that's something that you're going to have to study in your book. We're not quite there yet, but in an ANOVA, if there are significance, because there's more than 3 independent variables, we don't know which one made the difference. So you do a post hoc test that will identify which
They,
of those variables made the difference, or is some,
well,
Mhm.
they say that they use a Bonferroni test.
That's fine. Bonferroni is a post hoc. Tukey test is a post hoc. Yeah, there's a lot of different ones, and I don't care which one. It's
That's
just
what,
whatever. If the study tells you that, then you'll know. If not, you can just explain that, you know, a post hoc test like the Tukey test or the Bonferroni and what it does.
oh, okay. Okay.